This is another activity on algebraic expressions and identities. The objective of this activity is to experimentally verify the identity a square minus b square equals a plus b times a minus b. Let's study the concept in hand. Whenever you have the difference of two squares, that means a square and b square are to be subtracted, you can actually write it in factor form, which is a plus b, that is sum of the two bases a and b, and the product with the difference of the two bases a and b. So we have to just multiply the sum by the difference. Now, how did we obtain this identity algebraically? So if you see a plus b times a minus b, if you multiply these binomials, a times a is a square, a times minus b is minus ab, b times a is plus ab again, and b times minus b is minus b square. So you can see a common factor minus ab plus ab getting cancelled there, and you have a square minus b square, which is the required identity. So this is the algebraic proof of this particular identity, a square minus b square equals a plus b times a minus b. To prove this experimentally using an activity, you require some material in the form of a graph paper, scissors for cutting work, colors and pencils, etc. for drawing work. Let's perform this activity now.
For deriving this identity, a square minus b square equal to a plus b times a minus b, we have to first draw a square in which the side is a. So this is a and this is a. For simplicity's sake, I have drawn a square of side 5 centimeters. Now from this big square, the area of which is a square, the smaller square, that is the shaded one which I am shading here right now, this one is to be cut out. Let us assume that the side of this small square is b. So what are we left with? We are left with this area, right? So the area which we have cut out is b square and the original area was a square. So the leftover area is a square minus b square. It is represented here in this figure. We have cut out the smaller square and we are left with this part. Now what do we have to do with this? First of all, let's find out how much is this. Since the bigger square had a side a and the smaller had a side b, that means this part will be a minus b, which is 5 minus 3, 2 in this case. Here also, this was a and we have cut out b from this. So this leftover is a minus b. So this is also a minus b and this is also a minus b. And now what do we have to do with this figure? We have to cut it out along this line. And when you cut it out along this line, you will obtain two rectangles. So I have already cut it out for you. Here is the first one, this one, and here is the second one, which is here. Now what do we do with this? Remember, this is a minus b and this is also a minus b. So if you keep it like this and place this smaller one adjacent to this, this forms a rectangle. So let us see what are the sides of this rectangle. The sides of this rectangle are, this part was a and this was b. So the total side in this case is a plus b. So the length of this rectangle is a plus b. Likewise, this part, remember, it is a minus b. So what is the area of this rectangle? It is a plus b times a minus b. And what this area is equal to? You remember the area which was left over, this part was a square minus b square. So actually the same area was converted into this rectangle and therefore a square minus b square is always equal to a plus b times a minus b, and that completes our activity.